Here I want to do an example where information about an ellipse is given, and then you have to determine the equation of the ellipse. Okay, and before we do that, let me remind you what the equation should look like. It should be a squared x fraction plus a squared y fraction equals 1. Okay, and with, of course, numbers in the denominator, plus or minus numbers up here next to x and y. Okay, so that's what we're expecting here. Now, since we have all these ordered pairs, I think it will be useful to use a graph to solve the problem. Let's help us visualize here. Okay, so let me put a graph in here. So we start with foci at 2, 4 and -6, 4. Now, since those are my foci, I know several things already. I know I have a horizontal major axis, which means that my vertices will be outside of my foci here on this major axis. I can also figure out that my center is exactly halfway between. So those, let's see, those are 8 units apart, so my center will be 4 units over from one of them, so 1, 2, 3, 4. Here's my center. Okay, so my center is the ordered pair -2, 4. And I know that my center is related to the numerators of my equation, and they are the values that make those numerators equal 0. So since the x is -2, that means that my numerator is going to be x plus 2 squared, because -2 is what makes x plus 2 equal 0. Basically, they're opposites of each other. And then here I know that y equals 4, which tells me my y numerator is y minus 4 squared. And so now I know that my equation looks like this. Okay, it helps me with that part of it. So I have my numerators, which is excellent. All I'm missing now is my denominators. Okay, so I've used my foci here. Also, my foci tells me my C value. So C is from center to focus, so C is 4. So I know my C value is 4. Okay, then I know I have a minor axis endpoint at -2, 1, which is right here. And so that's going to tell me my B value, because it's the minor axis, it's B. So I know that B is 3, and I know C is 4. Now, in my equation, I've got to use my A and B numbers, my vertical and horizontal distances. So B is vertical. That means the B value is going to go underneath the Y fraction. So this is vertical, okay? So it goes under my Y fraction. So I put 3 squared, or 9. Because remember, my distances are squared in the equation. Now I need to know my A value, because A is my horizontal distance that I use. You never use the distance from a center to a focus in the equation. Use the points on the curve, and I know that my minor axis endpoints are on the curve, and my other one is 3 above my center. So I need my A, and I know B and C. And I know I have the equation for C, A, and B. C squared equals A squared minus B squared. I can solve for A. So C is 4. I have 4 squared equals A squared, I don't know, minus B squared, so 3 squared. So 16 equals A squared minus 9. Add the 9 over. I can see that A squared is 25, and taking the square root I can see A is 5. So that tells me up here, let's draw it in the graph over here first. A is 5. I need to go 5 units from my center. That gives me my vertices. 5 units left, that's going to give me this vertex. And my graph, my ellipse, looks like this. So I never use my c value because the foci are not on the curve. I use my a and b values to get my denominators. So here I use 5 squared, which is 25. And now I have the equation of the ellipse. So everything in the equation is squared. The x is squared, the y is squared, the a is squared, and the b is squared. The placement of a and b are determined by whether they're vertical or horizontal. A is 5 was horizontal. Okay, horizontal, right? I knew to go left and right because C was measured left and right. My major axis was left and right. So that tells me it goes in the x fraction. It's my x denominator, okay? When I found that B was 3, that was vertical. So that was in my y denominator, my y fraction, okay? So the bigger number doesn't always go with x and the smaller number always go with y. It depends on what direction they're measured. Use the distance directions to determine which fraction to use. Okay, that's the mistake I see most often as an instructor. Too many students make assumptions here, but the direction of the measurement tells you which fraction those numbers go in. And of course, if you've seen some of my other videos, you know that you don't always get nice whole numbers here. A could have ended up being the square root of 7. And so when you square the square root of 7, this denominator could have been just the number 7. They don't always have to be pretty perfect squares, but they can be. So I hope this example is helpful in getting you more familiar with the equation of an ellipse.